Long before the time of man, a sensitive, short-lived animal roamed through the oceans and rivers of the northern hemisphere, the salmon. Driven by an overpowering instinct, the salmon traveled across thousands of miles of open water and up through a maze of rivers to spawn in the stream of its birth. In an awesome display of energy and determination, the salmon overcame enormous obstacles, hurling itself again and again at raging waterfalls, only to face the threat of predators awaiting it upstream. In spite of a constant battle for survival, the salmon prevailed. And today, its distant descendants are still making the same journey homeward. Coho, Chinook, sockeye, pink and chum, adult salmon of all descriptions are irresistibly drawn back to the home stream after only 2 to 4 short years of life. The mystery of how these magnificent animals of enormous endurance find their way home to spawn and to die has captured the imagination of man for centuries. Regaled in ritual colors, bruised and emaciated, they reach their destination and go into this ancient spawning dance. Out of the 4,000 eggs that are laid by a salmon, about 100 fish will live to make the journey to the ocean. Only 10 will live to make the journey back again. Their bodies badly deteriorated and their energy spent, the salmon will die, part of a never-ending cycle of life and death. In this spectacular journey lies the enduring mystery of the salmon. The roots of the salmon story penetrate more deeply into the past than do the roots of man. Salmon predate man's existence by almost 1 million years. But as our prehistoric ancestors evolved and learned to hunt and fish, the great salmon became an important factor in their lives. The salmon's leaping image was carved on this antler bone 35,000 years ago by primitive man. Then, as now, salmon made good eating and good sport. Since ancient times, cultures have depended on, even worshipped, the salmon. But man still does not understand him. These Indians, the Salmon and Cedar people of the Northwest Pacific coast, here photographed in 1906, carved an entire culture around the salmon. They believed the salmon were human-like gods who lived in a great house at the bottom of the ocean. Each fall, the gods dressed in the flesh of salmon and swam upstream to sacrifice themselves for the benefit of man. The spirit of each fish subsequently returned to the sea. The Indians reverently returned each salmon bone to the river, for they believed that it was from the bones of the dead salmon that the gods resumed their human form. A primitive explanation for the salmon's homeward journey? Perhaps. But for the Indians, it was a logical assumption, for they could not have associated the adult migrating salmon with the tiny eggs developing in the stream beds. They never recognized as salmon the tiny sac fry rising from the nest. they never recognized as salmon the 6-inch smolts making their way downstream to the sea. In many ways, the salmon is still a mystery to us, hidden from us throughout most of its life. But where the Indians relied on superstition and myth, modern man relies on the methods of science to answer his questions. How do the fish find their way back home, often across thousands of miles of open water? What guides the salmon to that one stream in 10,000 that is his native stream?
I took my family after the war to the Rocky Mountains where I was raised. And in taking them along a pass, we reached a point in the passway that was next to a ravine. And at the mouth, up at the head of this ravine, was a waterfall. And the odors of that waterfall came around the edge of this cliff, you see, and I smelled them in the trail with not being able to see the waterfall.
In the early 1950s, limnologist Arthur Hassler suggested that once the fish find the right river, they might be smelling their way back to the home stream, like schools of underwater bloodhounds. Each stream, he said, might have its own characteristic odors that the fish learns or is imprinted to when young and remembers as a spawning adult.
But that odor then immediately set off in my mind's eye the names of school chums and Boy Scout chums that I'd played with in a meadow near that waterfall. So this struck me then, well, Arthur, you're a salmon coming home and it smells like home.
For the past 20 years, a series of research teams at the University of Wisconsin in Madison have observed, raised, tagged, tracked, and lived with salmon in an effort to understand their behavior.
And then the trend is now to take all of the data and place it in the computer.
Alan Scholes,
Fish's behavior,
John Cooper, Dale Madison,
changes
Peter Johnson,
indicate
Russ Horrell,
variances in its
and Arthur Hassler.
and then run this
Together,
through
they study the fish's migration through open water and near the home stream. In this experiment, graduate student John Cooper exposes a salmon to a variety of odors, including those from the home stream, and measures the fish's responses by recording its brain waves. The fish's nose is bathed in one of several solutions, each containing a different odor substance. A tiny electrode planted in the olfactory bulbs of the fish's brain transmits the salmon's responses to each chemical to a polygraph recorder. Cooper's findings? Of all the odors fish are exposed to, those of the home stream bring the greatest response. This and earlier experiments have shown that salmon can distinguish their home stream odors, and that without their sense of smell, migrating fish become disoriented and confused.
To really clean this up and convert it from a theory to a fact, because people were criticizing us that, well, how do you know it wasn't vision or the sound of the water, or had they memorized the path? And we didn't have any evidence for that. So I said the experiment we have to do then is to get a pure chemical that fish had never known in the history of their evolution and imprint them with this or condition them to it in the hatchery, mark them, let them go to sea, and when they come back, decoy them at some point downstream from where they originally conditioned with this artificial odor.
In 1966, the Michigan Department of Natural Resources brought Pacific salmon to the Great Lakes. Michigan and later other states, including Wisconsin, brought in the fish to revitalize the sports fishing industry, hard hit by the sea lamprey invasion that had wiped out large numbers of lake trout and whitefish, both natives of the Great Lakes. But salmon can't spawn naturally in the silty, turbid streams that run into Lake Michigan. Russ Daly of the Wisconsin DNR explains.
Well, the operation you're looking at is spawning a coho salmon, and this release pond, or this capture area now, has been in operation for 4 years. And what we do, these eggs now that you see us stripping, we will strip them, fertilize them, then they'll be taken to a hatchery where they're hatched on hatching trays. As soon as they hatch out, they live a normal life like any other trout in the hatchery for about 18 months. At the end of 18-month period, salmon will undergo a process called smolting. They turn silvery. Before this time, they're brought back to this pond, and they're held here for about 6 or 8 weeks. And during this period of 6 to 8 weeks, they undergo the smolting process, and at this time, it's imprinted on their senses a place to return. In other words, we're memory orienting them to come back to this specific water source.
With salmon practically in their backyard, University of Wisconsin scientists now had the perfect opportunity to test the odor theory. The experiment began at a water filtration plant in South Milwaukee. Here, groups of salmon are raised in the neutral water of Lake Michigan. During the smolting period, just prior to their release, half of the fish are exposed and imprinted to an artificial chemical odor. The rest are left to serve as a control group in the experiment. All of the fish are then tagged and released into the lake.
And so we then began to do this experiment, raising them first in a hatchery up to 6 inches, then imprinting them with this artificial odor, then pick them up in a helicopter and put them in the middle of Lake Michigan, and then let them grow up, and when they become sexually mature, see if you can decoy them back to the place, at some place along shore with this artificial chemical.
During the fall run, the scientists create an artificial home stream for the spawning salmon. They drip small amounts of the imprinting chemical into the water of Oak Creek, nearby the filtration plant, in the hopes that the odor will attract the migrating, imprinted fish. Scientists and members of the DNR are taking the Oak Creek salmon census. They use electroshocking, the technique which stuns the fish momentarily and brings them near the surface where they can be captured and counted.
We've been doing this near Milwaukee. The fish are coming back 20 experimentals to 1 control. It's magnificent results as though we've almost been cheating on it. So we now have, I think, if no one is going to be able to dispute this fact, that it is smell that the fish are conditioned to.
Hassler and the research team feel sure that they have found the underwater guidepost which leads the spawning salmon to his home stream once he is in the right river. But other facets of the salmon riddle remain. How do the fish navigate across open water? And once they encounter land, how can they find the right river? To find out, the Wisconsin team has spent many years on the trail of homing salmon in fresh and saltwater all over the northern hemisphere.
Yeah, it's a canvas tank with a truck tire underneath, and the tank is suspended from the frame so that when the boat moves, the tank flexes so the fish don't get sloshed around inside. The whole thing just sort of sways back and forth.
Peter Johnson and Jack Robinson are salmon trackers. For the past 2 years, they have tracked migrating salmon through the coastal waters of Lake Michigan. In the canvas tank are 3 healthy females that have already made the trip home to the Anape River in Algoma, Wisconsin. 30 miles south of the river, Jack and Peter will take one of the fish, tag her with a tiny underwater transmitter, and let her go.
Just ultrasonic transmitter. Today we're just going to do a standard ultrasonic straight tag track. strapped into the dorsal pin, and then gizmo like this. Here's an old temperature tag. Pins go through the dorsal pin, and the discs go on the other side, and they get cut off and twisted around. It's strapped right up on the back.
So that the fish will not harm itself during tagging, it is anesthetized and held in this position until it recovers and can be released. Using an underwater microphone to monitor the salmon signals, they will stay with her, tracking her progress over the course of many hours as she heads back to Algoma. The sound you hear is being transmitted from the back of the swimming salmon.
Well, out here we have to record the variations of as many factors as is possible to record, sort of trying to get a feeling of what's changing. What we record is environmental data, such as the position of the sun, its altitude, where in the sky the sun is, how visible it is, whether it's covered by clouds, and if it is covered by clouds, whether you can tell its location by rays or bright spots. Some of the other things we record might be wave height, wave direction, water temperature, various things like that. Just anything we can think of that a fish might be using as a cue.
Can I borrow that piece of lens right there? I can study the boat out a bit. Try to stay a little closer to her. I think she's starting to hurt. I'll stay closer to her, though. If she stays on the position the course she's on now, she'd run right into Algoma. Algoma is directly north along this path that the fish is following. She would get there in, let's say, 10 hours or so. That's averaging 2.5 knots. So she'd be there, she'd be there, what? A little after midnight.
The data gathered during this track and scores of others like it indicate that the salmon rely on a complex set of factors to navigate. There are theories that they use the sun, the stars, water currents, the Earth's magnetic field, gravity, or perhaps some unique sensory system as yet unknown to man.
Well, since for about, let's see, 1, 2, 3, 4, 5, an hour and a quarter, her path has been straight north, just almost as straight as an arrow. And for the last 15 minutes, she's been going more slowly than she had been for the 15 minutes before that. And the 15 minutes before this last position plot, she's going about 2.6, 2.7 knots. And now she's only going probably about half of that. But still in the same path, but a lot slower. She's probably tired. A lot of our fish did not slow down when dark descended.
But the scientists are at an impasse. They must now find out how a salmon perceives and integrates these factors to navigate across miles and miles of open water. When they know this, they will be as close as man has ever been to solving the riddle of the homing salmon. Jim Bell is the captain of the Doro Bell, a 38-foot charter boat out of Algoma, Wisconsin. From June to October, his boat plies the dazzling blue waters of Lake Michigan, unreeling a web of shiny, colorful lures, the trappings of a sport as old as man.
So it's really a growing industry as far as the sport fishing is concerned. This awakened the public that is near the lake of this, what is really happening out there. And it's bringing all the people out in small boats. You see sometimes people out there in canoes fishing for the salmon.
But you don't have to be on board a boat to reel in a spirited salmon. You can catch your limit and never leave the shore. All it takes is patience, perseverance, a little know-how, a little luck, and sometimes a loser's smile. In 1966, there were no charter boats working out of Algoma. Today, there are 19, with a total income of about $400,000 a year. New sports shops, restaurants, and hotels are springing up, and sports fishing is becoming a million-dollar business for Algoma and other coastal communities. The single word, coho, has had an almost magical effect, says DNR area fish manager Lee Kernan. Rainbow and lake trout inspired enthusiasm, but it was the term coho salmon that built the boat ramps and painted the billboards. A growing industry and a growing cause for celebration. Manitowoc, Sheboygan, Algoma. Towns all along the Lake Michigan coast are celebrating with annual festivals, fun, and prizes, all in the name of the coho salmon. The fishermen come in all shapes and sizes. The thrill of landing a sawtooth Chinook is a common emotion that unites us in its simplicity, an emotion that unites us with our past. But man's presence has changed the world, and with it the oceans and rivers of the spawning salmon. Rivers like the Rhine, once teeming with Atlantic salmon, now lie polluted and barren. Man-made dams block the once free-flowing rivers on the Pacific coast that carried such a wealth of salmon. The more we know about the salmon, its habits, and its mysteries, the better we can protect and manage this precious and increasingly fragile resource.
And when you realize that salmon and other marine fishes are a free resource, we don't have to haul them in manure, we don't have to feed them, they go out to sea and feed on a kind of food that we can't collect and with a lot less energy. And to destroy this wonderful stock of fish is really something that we ought to search our conscience about whether we've done the right thing.
Man and salmon. How will the story end? We gratefully acknowledge the help of the Wisconsin Department of Natural Resources, United States Coast Guard, the Charter Boat Association of Algoma, and the Milwaukee Public Museum.